And so now we have two presenters, Benjamin de Kosnik and Morgan Reschenberg?
Yeah.
Apologies. So Benjamin is a member of the Mozilla Performance Engineering team, and Morgan is a senior software engineer working on platform accessibility. And Morgan, if you want to repeat your name, probably with the right pronunciation.
No, you got it. You got it. Morgan Reschenberg, that's me. Yeah, we're going to talk to you about an accessibility project called Cache the World and the way that we're monitoring and measuring performance.
So I'm Benjamin. I am on the performance team, and I'm going to be talking about the collaboration from the performance side.
And I'm Morgan. I'm on the accessibility team. I'm going to talk about the accessibility side. We put the matrix rooms for both of our teams here, so if you have topic-related questions after this, you can follow up there.
So here's the agenda. We're going to just talk a little bit about accessibility in Firefox. Morgan's going to go through an intro to the rendering and accessibility architecture and some of the changes that happened with Cache the World. I'm going to talk a little bit about how we're measuring performance and some of those questions and current problems. We're going to go through our future work plans, and then we're going to open it up for questions. So the first thing is scope and context for accessibility in Firefox. The goal is, of course, a faster accessibility engine and more performant web use for users, all users, and especially users using accessible technologies. We also want to try to create a performance testing infrastructure that will be able to prove these things and test. The more we change our internal infrastructures, we want to be able to make sure that we can catch problems. We also wanted to establish some accessibility metrics, and we want to work in public with public dashboards that show the kind of performance that we're getting. We want to improve our documentation. We want to improve the debug experience. As such, we're going to talk a little bit later about the profile markers that Nazim talked about earlier, but specifically the accessibility ones. And we want to set up an infrastructure for collaboration. So scope on this is we're going to be talking about screen readers pretty much only. And we're not going to be talking about any of these other accessibility technologies like screen magnification, contrast modes, on-screen keyboards, subtitles, any of that. That's all deferred till later in this work. So context for Firefox and accessible technologies is not great from the free software perspective. Like almost all our users are on Windows, and then you have a very small sliver of Mac and Linux is like under 1%. We just have to know where we are, and that's where we are. In general, 5.5% of all Firefox page loads for the month of January had some accessible technology built in. And that's not evenly distributed across the OSs. We see a much higher use on Windows. And, Linux isn't bad. Orca, yay. And then Mac is far below that. But for the most part, if we were talking about who is touching this work and who do we have to care about, it's these Windows users. And then here, just for a little bit more context about in that 5.5% of page loads that use accessible technologies, what accessible technologies are they using? They're using mostly screen magnifiers, which is the black line. And then the purple line is speech rec in general. And then underneath that is NVDA, which is the Windows screen reader. So those are the top three that we really have to care about. Morgan?
Hi. And so before we get into all the details about the performance work, I want to give you some background on how rendering works in web browsers and how it translates to the accessibility architecture that we're going to be talking about today. So the general job of a web browser is to convert HTML and CSS written by web authors into visual navigable content, right? And we do this through a rendering engine. In Firefox, this is called Gecko. It has 5 different phases and stages that produce artifacts that are used in the following phases and stages. So first, we parse the HTML document. This creates the DOM, or document object model, which is a hierarchical view of the web page. Then we look at the CSS and figure out the style information for each node, what visual changes we need to make when we render. Then we do layout, which computes positional and size information for each of these nodes. It also constructs an artifact with that information called the frame tree, which becomes useful later. And then we do painting and compositing and rendering, which is the visual part of rendering. But this process is all extremely visual, right? And what if you do not navigate the web visually? What if you navigate it with technology like a screen reader, which turns visual content into audio? What do you do then? And how does a screen reader figure out what it should be telling you? Well, that's the job of the accessibility engine. So like we have a rendering engine, we also have an accessibility engine in Firefox. It doesn't have a fun name, so if you can come up with a fun name, you should let me know on Matrix. But what it does is it takes in those artifacts we talked about before, the DOM, the frame tree, style structs, etc., and it marshals them into a new kind of tree, which we call the accessibility tree, or I like to call it the accessibility tree, because that's more fun. But it takes all of those and computes accessibly relevant information. So this is stuff like semantic role, name, the kinds of actions you can perform on an element, things like that. This is not necessarily one-to-one, like there is not a single accessible for every node in the DOM tree or a single accessible for every frame in the frame tree. We care about different things, which is why we have to build a new structure. And building this structure happens in the content process. We have one accessibility tree per web page. So let's take a look at how these queries happen from an assistive technology standpoint. So at the bottom here, I've got a couple different kinds of assistive technologies. These are ones that Benjamin mentioned on that graph from before. So we have screen readers, voice control, window managers, etc. These clients, or ATs, make requests to Firefox for web content information. So if you are navigating with the screen reader needs to ask, what node is focused, and what should I say about it to the end user? The way that those requests happen are through platform-specific APIs, but they all hit the parent process in Firefox. The assistive technologies are separate applications, so they're communicating with Firefox through the parent process. Each web page lives in one or more other processes, one or more content processes, and is not reachable by the assistive technology directly. So we can't inject the screen reader into web content for a lot of reasons, security being one of them. All these calls go through the parent process. And there are some problems with this architecture that motivate what we're going to talk about next. So let's get into it. Like I said, computation of the relevant properties that the assistive technologies are requesting, that all happens using the accessibility tree in the content process. The result gets sent to the parent process from content via IPC, inter-process communication. This is slow, and it's also synchronous. So if a call gets blocked or is taking a really long time in content, you can't do anything. The parent process just hangs. And because the parent process includes all of the browser UI as well, it just looks like Firefox is not responding, which isn't great. So what can we do about that? Well, our solution is this project we call Cache the World, which introduces a cache in the parent process that keeps track of snippets of content information that we need to compute and respond to those API calls. So we're trying to offload as much work as we can from content into parent. And this cache gets updated asynchronously based on content mutations. So we no longer have this problem of synchronous blocking IPC.
Cool. So now I'm back, and I'm going to talk a little bit about how do we see if this stuff's working. So the first thing we did is actually not at all metric or measurement based, but it was more about helping debug in the profiler. So one of my great colleagues, Michael Kamala, added some accessibility markers in the profiler to kind of get us an idea what's going on where. You can see the specific calls here, and then I'm going to show you what it looks like kind of in the profiler. So the red circle is where we start to drop into some of the accessibility calls. So watch this space, because we're going to be adding more markers here. The second thing we had to do is really come up with, like, how do we test accessibility, and what's going on here? There's a huge amount of screen reader. There's just like a whole bunch of different screen readers, and they're all different, and each OS has a different strategy for dealing with this. So we have like a huge complex testing matrix here. In addition, we had to like, in terms of testing, we had to like run a large number of variations to kind of verify our results. We have 5 different variations starting with a baseline, and then we kind of like have caches on and off with the accessibility implicitly on by just plugging in screen reader, and also with accessibility forced on with preferences. So we have a really large matrix of 5 on our tests here. And then we were looking for specific problematic web content that would really trigger kind of the worst case scenarios here. And they are, in general, the worst case web content for this are really large static web pages. So what did we do? We added 3 specific sites. Actually, I think we have like 5 sites. But in general, it's like Wikipedia World War II is a great test page for testing accessibility. We have some search box links because we're Firefox engineers. And then WG HTML specs. So these kind of like really large static pages, which is not necessarily how a lot of the web is built right now. But these are like specific problem points that we wanted to be aware of and address. And then comes the question of like, well, what are we measuring? What's important? And we have like 3 general choices here. We have like W3C, navigation timing, kind of page load metrics like OG performance metrics that segment browser page load into distinct phases, DNS, redirects, DOM parsing, and then like content ready, pages loaded. We usually traditionally use visual metrics, but because of the nature of this, nope, can't do that. And then we have some kind of internal benchmarks that are not really publicly accessible, where we just try to look at specific code flows and time and measure. And that's really showing the most promise, frankly, and what we're going to be using more of in the future. And so what we're trying to work in public, and we have some public dashboards for this work, which are at the end here. Whoops, sorry. So this is like some preliminary results. This graph's a little hard to understand, and I'm sorry about that. We have the blue baseline performance. We have these dotted lines with the caches turned off. And then we have with the caches turned on. And so we're seeing like, not great performance for these static web pages right now, at least on Linux. I think that actually varies on Windows. But we're seeing some wins and some more even performance on things like IMD web pages, which aren't like these pathological test cases. So in general, what we're going to be doing is we're going to be trying to align the profile markers that were put in to performance metrics using our internal tools at first. And we're just going to try to start measuring like the actual cache creation time. And we also want to start paying attention to not just straight classic page load, but we want to start thinking about page reload, tab switching, and one of the other leads on this project, Jamie T, has a great blog post about those kind of like anecdotal performance measurements. We definitely want accessibility first metrics, and we would like to get away from generic page load type metrics on this. We have a public dashboard, work in progress. It will continue to evolve as this work evolves. And then really quickly, future work.
Yeah, so the accessibility team at Mozilla is responsible for a lot more than just the accessibility engine. We're also responsible for high contrast mode, Zoom, Firefox front-end usability and accessibility. So we've got a lot of projects apart from this that we're working on, but our main goal for this half is to ship Cache the World to release. We're currently in beta, and we have a lot of promising results, so we're really optimistic about getting this to all of our users. We're also planning on working on optimizations based on the performance work that you're seeing here. We have a couple of optimizations in mind. Like, we know we can improve on cache granularity, but this work will inform the kind of work that we're doing next.
And then the performance team is going to really try to get these Windows results in, since we know it's so important. At the same time, we want to make sure that Linux performance doesn't degrade. Also, we would like to kind of like put this into standard continuous integration test infrastructure, kind of tune our markers, make sure we're measuring what we think we're measuring, and then things that we deem successful in a wide variety of web content, we want to try to push out to public telemetry so that we can actually measure much larger environments and users. And then, of course, all the internal collaborations inside of Mozilla with perf tools and ETL and DevOps to try and make all the magic happen. We have some questions. If we have time for questions, we have time for questions.
We have time for questions.
Fantastic. And if you have other thoughts, you can email us or, Twitter.
And I'm on Mastodon.
I'm not.
Okay.
I'm on Twitter. Thank you.
Are there any questions? No
All right.
questions? Everything was perfectly
So
clear?
complete.
Killed it.
Yeah.
Well, if you want to add something else, or you have 5 minutes.
We actually, on the slide deck, but not in our presentation, we did have, we have some additional resources and notes for people who are trying to work with accessibility, maybe new to it, and things that, here's some resources for you to use. Again, Jamie's blog post, really, I'm going to really hype that again. Please read it. Morgan is going to put a video up that has to be redone because there was some internal stuff that can't be shown. But she has a great walkthrough about how to debug CSS for accessibility. And then I have a webpage on color and contrast for accessibility and like how you can compute colors that work for a wide variety of people.
And also, I want to shamelessly plug that you can contribute to Firefox.
Oh yeah,
and
thing.
If you are interested, if you're interested in working on platform-specific bugs or front-end bugs or whatever, accessibility is a great place to get involved because we span a lot of components, and we could always use your help. So if you are interested, we have an accessibility room on Matrix at the Mozilla domain, and you should reach out, and we're there. So.
Finn.
Yeah. Oh, great. Oh. We'll take a question.
Hi, so you mentioned it's not safe to embed the screen reader directly into the web page because of security concerns. Mm-hmm. But now with caching, you're providing a little bit more information to this parent process. Are there any security considerations you had to look at or address doing this work?
We're paying attention to the kind of information that we're caching. We, of course, don't want to give any private user information away. Largely, the information we're caching is already represented in the parent process in some form, but the way that we compute things is different than how DOM or layout or other parts of the browser compute them. We're caching really, really granular information as well. So yeah, we're not currently concerned about security risk, but that is a consideration.
Oh, cool.
Maybe you already said, do you have performance tests with accessibility enabled right now?
Yeah, that's what that website is.
Oh, sorry. The question was, do we have...
Do we have tests with accessibility? Are we performance testing for accessibility? Yes, we're starting to do that. And
is it just a matter of enabling accessibility and running exactly the same tests, or are you doing something different for accessibility?
yeah, so we're... okay, so the question is like what's the method there? And you can contact me offline if we're running close. But we're using a standard a framework for performance testing called Browser Time, which is open source. And yes, what we're doing is we have OS-specific handlers that basically start screen readers before we start running that, and then stop it when we're done. So it's just RAI straight style on that, yeah. And then porting that to Windows too.
One of the difficulties with that approach that we're running into is that we are most interested in perceived performance. So we want to know, how does the user feel about this? Like, is it perceivably faster? And that's really hard to do because screen readers are difficult to automate from that perspective. Speech rate is extremely variable.
Right.
You can do key presses and stuff, but it's really hard to get the kinds of measurements we want. So we're aware that the performance testing we're doing right now is a number, and it's something that we can track consistently, but it isn't entirely what we would like to be.
And there's different strategies on the Windows screen readers about like having to have the full page ready before we actually start in with the speech. And that's like configurable, and that's not the default setting on Linux, for instance. So Orca, I think, is actually pretty smart about this, and they can do partial reads and start the speech earlier. So we're not getting quite.
We have a comment on Matrix.
Oh, sure. Note that the caching in the parent moves information into a process that is not exposed to web content. Oh, there's nothing before that.
It's not appearing here. Maybe, yes, here.
Oh, can you talk about how the cache is populated and invalidated?
Oh, sure. How much time do we have? 2 minutes. Okay.
Yeah, go.
So the cache is populated from content. So it's a push-based cache. We aren't invalidating from parent because we can't observe content mutations from parent effectively. Each content process is responsible for monitoring their own mutations and pushing or invalidating stuff in the parent process as needed. We have an initial cache push that, oh no, sorry. On page load, we collect a bunch of information and push it always, so there isn't any sort of mutation that we're responding to there. That is one of our big performance concerns, is the initial cache push varies by page size or scales by page size, and that's really costly. But
that's why you put all those big tests in there. Yeah.
But from initial cache push onward, we're responding to mutations in content from content. Yeah.
Are there any other questions?
Oh, yeah. We're going to the limit.
On the web app side, what may impact negatively the performance of the accessibility?
Like, how could you design web content such that it's optimal for accessibility? Right. That's a great question. And we'll come back at you later with an answer. Yeah, we're still like kind of early phase on this, but I feel it would be a great idea to do some kind of like web content help to get people to know like the performance choices they're making for accessibility.
Yeah.
Maybe even linking, some tools for linking.
Oh yeah, could we come up with some guidelines for performance linting and general guidelines for how to do performance accessibility? Request submitted. Thank you.
So thank you very much.
Cool.
We are done.
Great.